everyone, welcome back to the channel. So today in this video lecture we'll be implementing the Dijkstra algorithm that we discussed in the previous video. So if you haven't watched that video, so please make sure to watch that video before you watch this video, because only then you will be able to understand the implementation of this algorithm. So let's take a quick recap. What do we do in Dijkstra algorithm? Basically, we have a graph which has n vertices numbered from 0 to n. We have a source vertex in this graph. For this case, the source vertex is node number 2, and we want to find the shortest path from this source vertex to all other nodes of the graph. That's the target. So how do we solve this problem? Now the graph is weighted obviously, and the weights are positive. Okay. Now let's see how we can solve this. Now we know how to solve this problem using Dijkstra algorithm. Dijkstra algorithm basically uses a distance array which it uses to store the distances for each node of the graph from the source node. So we have a certain shortest distance starting from the source node till each node of the graph, and that distance is stored in this distance array. Okay, so we have a distance array and we have a position corresponding to each node 0, 1 and 2. Okay, now in the priority queue we'll push node number 2 along with its distance, which is 0 initially. So this is the pair that we're going to push initially, node number 2 along with its distance from itself, and the distance for node number 2 would be 0. Okay, now we'll iterate over this priority queue till it is not empty, and we pick the node with the least distance from the source node. So initially we just have the source node in the priority queue, so we pick up this node, we pop it out, and we traverse its adjacent nodes, and the adjacent nodes of node number 2 are node number 0 and node number 1, and we perform the relaxation. So initially the array stores infinity for all these nodes. So for node number 1 and node number 0, the array has value infinity, and if I calculate the distance till node number 0, starting from node number 2, it would be the distance for node number 2, that is 0, plus 6, that is 6, and 6 is better than infinity, so we're going to update the distance for node number 0 to be 6. So again it works on the equation that is, okay, so in this fashion the weight will be the distance will be updated for any node. So for node number 0 it will be updated to 6. Then for node number 2, for node number 1 it will be updated as 0 plus 3, that is 3. So 3 is less than infinity, so we update here 3. Fine. And we also push these nodes for which we are updating the distance into the priority queue. So we're going to push node number 0 along with its new distance, that is 6. Then we'll push node number 1 along with its distance as 3. Fine. So then now again from this priority queue pick out the pair with the least distance from the source node. That would be this pair 3, 1. Okay, so for node number 1 I'm going to iterate over the adjacent nodes of this node, that is node number 0 and node number 2, and try to update the distance for them. So for node number 0 it would be 3, which is 3 plus 1, that is 4. So 4 is better than 6, which is the distance which we already have for node number 0. So we're going to update the distance for node number 0 to be 4, and we'll push node number 0 here along with its updated distance. For node number 2 we can't update because we have already best distance, that is 0. We are starting from the source node. Then again from this priority queue we can see that we will pull this pair, that is node number 0 with distance to be 4. So for node number 0 we have distance to be 4. Now traverse its adjacent nodes, that would be node number 1 and node number 2. So for node number 1 the distance would be 5. So because simply we came from node number 2 to node number 0, it gave me a distance of 4. So if I go back from 0 to 1, it will obviously be greater than the distance that I already have for node number 1, that is 3. So there is no point in updating the distance for node number 1. Same goes for node number 2, because we are starting from this node and we would have the shortest distance for this node, for the source node. So this pair will be popped out. In the same way, node number 0 with the distance 6 will be popped out, because here we have distance 6 but we already have a better distance for this node. So in this fashion, we will have our distance array computed at the end of this algorithm when this priority queue is empty. And finally, we will return this distance array, which stores the single source shortest path distance for every node of the graph starting from the source vertex. So let's try to implement the solution. Okay, so I will be implementing the solution first in C++ language. So here I am declaring a macro inf, which will be used to initialize the distance array with a very large number. So this is 10 raised to the power 9. So let's create a class solution in which I will declare my function Dijkstra. This returns a vector distance which stores the shortest distances starting from a source node. So I will pass in the number of nodes and the vector, the adjacency list. Then let's declare the distance array. It will have a size of n because the nodes are numbered from 0 to n minus 1, and it will be initialized with infinity. And it also takes in another variable, that is source, src source. So distance for the src variable source node will be 0 because we are starting from that node. Then declare a priority queue of pairs okay, and this is comparator pq. Push the initial node, that is src, with its distance into the queue, iterate over the queue till it is not empty, and pick the top node from this priority queue that contains two integers, the weight or the distance and the node itself. So pq dot top. Then check if this distance in the is compare this distance with the distance that I have for this node in the distance array. If this distance is less than if this distance is greater than the distance that I already have in the array, I don't have to update its neighbors, just continue to the next pair. Otherwise, iterate over the neighbors for this current node and check if there is a scope for relaxation over the neighbor nodes. So if there is a scope for relaxation for the neighbor nodes, that I will check like this: distance plus the weight. If it is the case, then I'm going to update this distance with dist plus wt and push this into the priority queue 2 with its new weight, that is distance 2, and the node itself, it is 2. Okay, so in this fashion I will have my distance array prepared, which I will be returning from the end of this function, return distance. Okay, so this is the implementation of Dijkstra algorithm in C++, and let's just update this a little bit. Here you have to pop this node as well. Okay, so I am removing the top node from the priority queue, and it has two variables, distance and node. Fine. So in this fashion I will be moving ahead. So here we are, here we are calculating this distance array. Okay, now, okay, so let's try to submit this solution over a platform. So let's try to submit this solution. Okay, so let's submit this solution. Okay, it worked. And okay, so in this fashion this algorithm works, and this was the implementation in C++. Let's see the implementation in Java language. Okay, so in the Java language we'll create a class, let's call it solution class, and in this solution class we'll create this function. So we'll create this function static int which returns an integer array, let's call it Dijkstra function, which takes in the integer and the array list. Integer which takes in the array list of integers, let's call it adj, and the source vertex. Okay, so in this fashion this now let's declare an distance array here. So let's declare a distance array, int distance new int of size n, and initialize it with a very large number. So here you have to take a very large number. Let's take it infinite to be 1, 10 raised to the power 9. Iterate over this distance array and initialize it with infinity. Then declare a priority queue. So and initialize the source to be 0. Then you have to declare a priority queue of pairs where you have to store the node and its distance pair. So for that you have to declare a custom class, let's call it pair class. So let's create a pair class which has two variables, distance and node, and so let's create a constructor which takes in this distance and this node and initialize the object with the given distance and the given node. Okay, fine. Then we'll declare a priority queue of these pairs. Pair, let's call it pq new priority queue, and let's take a pair x y. So these, we know that these pairs will be sorted by the distance. So x dot distance minus y dot distance. Fine, so they will be sorted by the distance. Then we'll iterate over this priority queue till this priority queue is not empty. I will iterate over this queue. Then finally, so extract the top pair. So there are two elements. The first is distance, that would be pq dot peak dot distance. So this represents the distance, and we'll have node pq dot peak dot node. Then we'll check if the distance in the distance array for this node is already better than the distance that I have here with the pair. In that case I will continue, otherwise I will iterate over the adjacent nodes. This is the adjacency matrix dot get the adjacency list for this node, then find the size of this node, and find the edge weight and the node and the adjacent node. Now check if the distance of this adjacent node, that is distance for this adjacent node, is greater than the distance that I calculate like this. That is, there is a scope for relaxation. So if I can perform this relaxation, then just perform it, dist plus edge weight, and push this new pair into the priority queue. So here you will have to remove this pair as well. So say remove, we'll use remove function, and then here I will use pq.add function in Java. New pair, in the pair we have to push distance of adjacent node and the node itself, that would be adjacent node. Finally at the end I will return my distance array. Fine. So in this fashion this is working. Let's see if there is a problem. Let's see if we find any problem in this code by submitting it on the okay, so let's see. Okay, there is an error, that is we are printing something else, adjacent node. Okay, what is the problem here? Okay, we are not initializing our priority queue, we have to initialize it with a pair, that is source vertex, which is src, and its distance, which is 0. Let's see now. Okay, let's try to submit. Fine, so it worked. Okay, so that was the implementation in Java language, and that's all we have to discuss. In the next video we'll be discussing about its optimizations, because you can see here, observe that I inserted node number 0 with two distance values. Initially we had 6, then I had 4. So these are duplicate entries for the same node with a varying distance. So how can I just avoid this? How can I avoid duplicate entries? How can I use a better priority queue? Why Dijkstra algorithm doesn't work for negative edges? We'll answer all of these questions in the next video. So stay tuned with me. I hope to see you all in my next video.